Hello, and welcome to the optional training SAP Automation. In today's video, you'll learn about automating this widely popular platform for enterprise resource planning. Generally, SAP has been quite tedious to automate, but by the end of this video, you'll see that UiPath makes the whole process rather painless, whether your SAP configuration has scripting enabled or not. Most techniques you'll use are fairly standard, things like automatic recording, manually inserting click text actions, sending keyboard shortcuts, extracting text, and a couple of SAP specific approaches too, because it does have its own peculiarities, and while you could work your way through them on your own, we'll give you a few tips and tricks so you can hit the ground running. As a testing platform, we'll use two human resources forms, or transactions as they're called in SAP, one displaying employee history, and the other for adding new employees. But before you start automating, you should enable SAP scripting, both on the local machine where the robot will run and on the server. It's a setting that needs to be performed only once to give UiPath direct access to SAP's interface. To enable it on the local machine, on the toolbar, go to the last button, Customize Local Layout and Options. Then go to Accessibility and Scripting, and Scripting. Here, you'll need to enable scripting and disable the other two, and hit OK. For the server, log on to the SAP server and go to transaction RZ11. Here, for the parameter name, type SAP GUI /user_scripting and enter. In this window, press the Change Value button on the toolbar and set the new value to True, and click Save. And that's all. If, for whatever reason, enabling these options is not available to you, then UiPath will not be able to uniquely identify some UI elements, so you'll need to apply other methods that are still 100% reliable. Right, now that's taken care of, we can start automating. When you first open SAP, you're greeted with a logon window. We also have the recorder open, so normally you'd go to Connections and double-click the server you wish to connect to. When trying to record these steps, we encounter the first SAP quirk, and the one that you'll encounter most often, especially without scripting enabled. The two panels are seen as blocks, even though the toolbar buttons and other elements are identified individually. Fortunately, the solution is quite simple. We'll use a click text action. Exit the automatic recording mode and manually add a click text action by going to Text, Mouse, Click, and then indicate the desired element. UiPath will show the screen scraping wizard. If this is your first encounter with it, here's how it works. This is the preview area showing you the text elements identified inside the selection you've just made. The next step is to copy from here the exact text corresponding to what you wanted to click on and paste it here in the text to be found field. And that's it. Now when you click continue, UiPath will perform the click, in our case on the connections folder, showing the list of servers. Here you can use another click text to start the SAP session. Again, in the recorder, go to Text, then Mouse, but this time to double click to start the connection and click the desired region. This shows up a bit more information than the left pane because this selection included the headers of the text box too. No matter, just fill in the text you want to click on and you're done. But don't click continue yet. Let's see what other options we have for this click text wizard. This one is purely informative. It just tells you the current scraping method. Native is automatically chosen because it's 100% accurate, unlike the OCR method, which can have slight imprecisions. And these two buttons let you pick another element or region to scrape. Below the preview, occurrence is for situations where multiple instances of the same text are present in the selection. It allows you to choose which instance is the correct one. Set mouse position is useful when you want to click somewhere relative to a text element. You'll see a bit later on a different example of how that works exactly. And test click performs an actual click so you can check if and how the click text works. When you click continue, UiPath will perform the double click and the logon window pops up. This is a pretty standard window so you can record interactions with no issues. We'll fill in the username, password, and add an enter at the end to proceed. If you'd like to use operating system credentials for a secure login, you should have a look at the Windows Credentials article on our website. Let's stop the recording and see the generated activities. We have the click text that selects connections, the one that double-clicks the server, and the typing of the user and password. So far, so good. Let's start a new recording to see what other automation quirks we can identify. In the beginning, I said we'll use two SAP personnel management modules. They're available here, deep in the menu, but we'll use a shortcut to access them. Simply type the code of the transaction that we want to bring up in the command field up here. The one we'll use now is called PA10, but all modules have special codes, so it's a quick and reliable method of opening them. This module is for viewing employee information starting from a valid employee ID. You can type the ID and some basic information will show up. The interesting element is this little button that appears only when this field has focus. It's used extensively throughout SAP's interface, and it can be a bit slippery. It opens a window that helps you fill in the current field with data. In this example, find an employee ID by adding and combining filters from the left pane. Let's say you need to find in SAP a user based on nationality and marital status. It's not necessarily the most useful example, but you'll learn how this type of buttons and controls can be automated. So, for each added filter, you can type a value here, or if you don't know it, click the little button associated with it, and double-click any of the options to use its value. These are the same types of buttons as the ones that open this window, but for different data. And then click Finish to bring up the result list, showing all the employees matching the set filters, and finally, double-click any one of them to use its value, and Enter to display it. This screen shows some basic information about the user, but for a detailed view, you need to press the Display button. Notice how the tooltip shows its keyboard shortcut too. It's very useful because this means we can reliably use keyboard commands to do various actions, especially since most important buttons have associated shortcuts. Here you can see a more detailed history for an employee, but it's read-only and you can only extract information. All these elements are easily accessible through the recorder though, so it's no problem here. Good. Next, let's see how to automate all these steps, because there are a few tricky parts. After the login, this is the main screen that you're presented with. The automatic recorder works on most toolbar buttons and elements, but not on this menu tree. It's all one block. We were planning to use a shortcut anyway, so just type the transaction code PA10 here and add an Enter key. On this next screen, we have a couple of options for the employee ID field. The simplest is to click here, type the ID, and add an Enter key. There's nothing more to it. The other option is to press its little button, but the recorder cannot directly press it, and on top of that, it automatically hides when this field is not selected. But here's a very easy workaround. Hit Escape to pause the recording and add the first click action to activate the button. It shows up briefly but disappears when the window loses focus. That's okay. Add a second click action and notice that the window and text field are now active and the button is clickable. And here's the pop-up. If before you got a chance to click the button, the text field somehow lost focus and the button is not showing up, you can hit the F2 key to temporarily pause the recording, click to focus it, and when the countdown finishes, recording resumes and you can finally click the button. And that's all. Now let's see if it worked. Here's the type that starts the transaction PA10, the click that activates the button, and the actual pressing of the button. First, let's test it. Okay, looks like it's working. Let's take a closer look to see how. As you can see, the only difference between the two clicks are the offset coordinates. The offset is calculated relative to the indicated element, or from its top left corner to be exact, resulting in a click that lands exactly on the button every time. For practice, let's delete these two generated click actions and recreate them manually. So, add a new click, indicate the text field, and duplicate the activity. The default click position is in the center. We'll change that to the bottom right corner instead, because it's closer to the tiny button, and add an offset of a few pixels. -5 pixels on both axes should be okay. In case you're not familiar with screen coordinate systems, positive axes are to the right and down. So that's how you interact with ephemeral UI elements, by simulating human actions that activate the desired element. Further on, let's see how to expand these folders and click the associated checkboxes. Automatic recording won't work because individual elements are not accessible, so we have to fall back to the click text method used earlier, but with an offset. Start by going to text mouse click and indicate the area. In the lower box, we'll copy the text we want to click next to, personal data, and to offset the click, use set mouse position. Manually indicate the position on the little expand arrow. And that's it. Hit continue, and the click will be performed. Then repeat the process for the other two checkboxes. Add a click text. Copy the name of the element, and set mouse position, this time indicating the checkbox. On the right-hand side, most of the elements are accessible through automatic recording, but these specific text fields don't trigger an input field. It's no problem. We'll just manually add a type action for each field. And a few more. A click to accept the changes. A double click to choose an employee, and another click on the View button. In this screen, all the fields are readily accessible, so we can get any piece of data we need, no issues here. But there are some controls that can be a bit tricky to extract: tables and checkboxes. All individual table cells can be read, but what happens when you want to extract a whole column, or the full table? To see that, we'll first start from a single cell. Let's save and exit for now and take a look at what we've recorded. The first action clicks to the left of the personal data text found on the screen, on the expand arrow. The negative offset on the x-axis is a good indication of where it performs the click. The other two are similar, but with a positive x offset, which means they will click to the right of the indicated text on the checkboxes. The next ones are simple type actions, clicks, and a couple of get values. It's pretty standard. The last one, though, it extracts a table cell value, and we'll use it to extract a whole column or row from the table. For easier testing, we'll cut it from here and paste it in a new sequence. Perfect. If we take a look at the selector for this get value activity, we notice the row and column are explicitly written. That's quite handy because it means we can use a while loop to cycle through all the rows in the table. So add a do while, set up a counter for it, and move the get value inside the loop. Now open its selector, locate the table row argument and delete it. In its place, simply put the counter variable. Oh, and remember that numbering of rows and columns starts from 0, so the first row is row 0. Okay, now add a write line to print it all out, and run. And here they are. Of course, you can apply the same method for multiple columns, or for rows, or for whole tables that you can extract and use further however you want. A special case for this extraction technique is when you don't know the number of rows in the table. Well, what then? Well, the solution is a bit counterintuitive, but it's also quite simple. It's based on the fact that in SAP, you can't read outside of a table. There's nothing there. So, if UiPath tries to read after the last row, it will throw an error. And here's how to exploit that in UiPath. Modify the do while to make it loop forever. Then add a try catch activity. And move the entire do while loop inside the try block. Technically, that's all. Now, when the counter goes beyond the last table row, it will encounter an error that will be caught by the catch block, so it won't actually fail. We'll also give the getValue activity a shorter timeout, because its failure is what will trigger the catch. Then, add an all-encompassing system exception. And just for illustration purposes, throw in a write-line activity. And when we run, we see the results, followed by the catch message, which means everything went smoothly. And the other element that requires a bit of special treatment, the checkbox. You can click it on and off and use regular recording, but to get its state, you have to read its attributes. It's fairly easy. Use the aptly named getAttribute activity and indicate the checkbox. UiPath will read and expose all its properties, but the one you're interested in is this one, checked. Then create an output variable, we'll call it checked, and show it in a message box. And here it is. Okay, as you've seen, output methods are pretty easy. All elements are accessible in the usual manner. You only need to set up some loops for tables and get attributes for checkboxes. And this brings us to the end of today's training. I think that by now you'll agree that SAP is generally straightforward to automate, with a few quirks here and there that have simple workarounds. The main takeaways of this video should be these. When automating SAP, start with recording the actions. Most of the time, it'll work fine. To interact with unrecognized elements, you can use click text and click image and keyboard shortcuts to reach difficult buttons or menu items. When dealing with an elusive UI element, like the tiny button to the right of some text fields, simply find a way to recreate the actions a human would do to activate that element. For tabular data, you have to use loops, although that's hardly SAP specific. The interesting part is the special case of reading a table of unknown size. The technique you saw was to read each row in an infinite loop until the operation fails. All that in a try-catch block to prevent an actual failure. And for reading special elements, use the getAttributes activity. It shows a bunch of hidden information that can prove very useful. And that's about it. Till next time, goodbye.